Hello everyone! Today, I'm going to show you how I transform old, used batteries into an incredibly versatile DIY tool. You might think these batteries are destined for the trash, but in just a few minutes, I'll reveal how to turn their core components into something amazing. A multi-purpose tool that can melt plastic, weld metal, and so much more. First, I carefully remove the outer metal casing of the battery using a pair of pliers. After completely removing the shell, I will use a box cutter to cleanly remove the plastic layer on the battery. Then, I use pliers to carefully remove the metal positive terminal cap from the top of the battery, then pliers to gently pull out the carbon rod. To ensure maximum efficiency and conductivity for our tip, I'll clean the exposed top of the carbon rod thoroughly with paper. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. To make our carbon rod tip precise and effective, I'm securing it into a drill chuck. Then, using sandpaper pressed against the spinning tip, I'm refining it. This process allows me to create a sharp, fine point, which is crucial for precision work when we use our new tool for various tasks. This ensures a clean and effective tip for our new tool. Once I'm happy with the sharpness, I remove the rod from the drill. Next, I've got a small wooden dowel that will serve as the handle for our tool. I'm measuring and marking a precise spot on it. This mark ensures that our tool's main body will be of an appropriate length for comfortable grip and balance. Now, I'll secure the dowel firmly in my vise, making sure it won't move during the next step. Using a hacksaw, I carefully cut along the marked line. After cutting, I'm marking the exact center of the cut piece. This is where we'll drill a hole. By clamping the piece back in the vise, I ensure stability for accurate drilling, which is vital for the copper pipe to fit perfectly. Using my drill, I'm carefully making a hole right through the center of the wooden piece. This hole is specifically sized to allow our copper pipe to pass through it securely, creating the main structure of our handle. Just look at that clean hole. This precise drilling ensures the copper pipe will fit snugly, preventing any wobbling during use. Now our wooden handle is ready for the next stage. Here's a length of copper pipe. Copper is an excellent conductor of heat, which is exactly what we need for efficient transfer to the tip. I'm inserting the copper pipe into the drilled hole in the wooden piece. It's a snug fit, which is good because it will provide a stable connection. I'll tap it into place gently with a hammer to ensure it's firmly seated and won't wobble. To achieve a sharper bend and make it easier to work with, I'm using a screwdriver as a lever. By carefully pressing and bending the copper pipe, I'm creating a precise curve. This ensures the tool is ergonomic and functional. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. I mark a small pilot hole at the very tip of the bent copper tube. I've placed the copper pipe on a wooden block for stability and to prevent it from moving while drilling. Using my drill, I carefully create a small pilot hole at the marked spot on the copper tube. This small hole will serve as connection points for our heating element. I'm now threading small screws into the newly drilled holes in the copper pipe. These screws will act as a secure clamp for our graphite tip, ensuring good electrical contact and mechanical stability, which is vital for effective heat transfer. It's time to connect the sharpened graphite rod to the copper pipe. I'm inserting the tip into the bent end and securing it with the screws. Make sure it's tight. This is where the heat will be generated and transferred from the electrical current to the tip. Next, I'm taking a length of red electrical wire. I'll strip one end and carefully thread it through a small hole I made at the base of the wooden handle, near the copper pipe. Then, I'm wrapping the wire tightly around the handle. This provides the electrical connection to our heating element and also makes the handle easier to grip and less prone to slipping. To ensure everything stays in place and for added insulation, I'm wrapping the handle with red electrical tape. This not only secures the wire but also creates a comfortable and non-slip grip. It's important to wrap it tightly to prevent any movement and make the tool durable. I'll finish by cutting and neatly securing the tape. Now, I'm stripping the insulation from the other end of the red wire. This exposes the bare copper strands for connection, ensuring a clean and efficient electrical contact. I'm attaching an alligator clip to the stripped end of the red wire. This clip will connect to the positive terminal of our power source. Providing the necessary current to heat our soldering iron. I'm repeating the process for a white wire, stripping one end wire and attaching alligator clips. The alligator clips provide a convenient and secure way to make temporary electrical connections, which is perfect for prototyping or portable use. For power, I'm using a 12-volt battery. I'm connecting the red alligator clip from our tool to the positive terminal and one of the blue alligator clips to the negative terminal of the battery. The other white clip will be our ground, completing the circuit when it touches the metal surface. Now for the truth. I'm testing our homemade soldering iron. Look at that. It heats up and glows, ready to work its magic. Now, I will attach these two blades together. The electrical current from the battery heats the graphite tip, allowing us to perform various tasks with precision. Watch as I touch it to this piece of blades. It melts through effortlessly, creating clean cuts and openings. This demonstrates its incredible effectiveness for tasks like plastic welding or precise cutting. This little soldering iron is incredibly effective for quick repairs and hobby electronics. It's truly amazing what you can create from a simple battery. Watch as I use it to melt through a metal plate and a nail. This demonstrates the intense heat and versatility of our DIY soldering iron. It's stronger than it looks. I connect the blue alligator clip to the metal plate. Then, I use our tool to heat the screw. As I apply power, you can see it heating up and glowing brightly, capable of performing small-scale welding tasks. It glows bright orange, demonstrating its capability to heat metal effectively for various applications, like marking or even simple welding. This compact tool is proving to be incredibly versatile. To cap off the epic performance, I demonstrate its ultimate strength by soldering the broken handle of a metal cup. I attach a blue alligator clip to the cup, then use our tool. Within seconds, the soldering iron begins to heat up rapidly, visible with a red glow. The carbon rod melts and reattaches the cup handle to its original state. It's incredible to see the power this simple device holds. From melting plastic with precision to demonstrating small welds, and even quickly heating up metal, this tool truly redefines what's possible with repurposed materials. The applications are endless for any DIY enthusiast. So there you have it, a powerful and versatile DIY tool made from just a few household items. I hope this project inspires you to look at everyday objects differently. If you enjoyed this transformation, please give this video a big thumbs up, share it with your friends, and leave a comment below letting me know what you'd create with this tool. And if you haven't already, subscribe to my channel for more exciting DIY hacks and inventions. Thank you so much for watching, and I'll see you in the next video.